Hello and welcome to our project on flood prediction and modeling for Calgary and Denver. We'll first go through how we build the model based on Calgary and then use the model to predict for Denver. Calgary is a city in Canada, Denver a city in the US. It shares many similarities with Calgary in terms of climate and geography, such as high altitude and near water bodies. As environmental problems worsen, flooding has become a problem for many cities. For example, in recent years, Calgary has experienced several floods that have caused significant damage. Urban planners nowadays are facing challenging problems when it comes to choosing cities' future development sites and construction plans to manage the risk of flooding. Traditionally, planners have relied on historical flood data and relevant models to predict the likelihood and impact of floods. Now, new approaches are needed to help cities prepare for floods. The goal of our project is to use machine learning to predict the probability of flood inundation in cities based on their geographic features. Now, let's dive into the details of our methodology and results. Our first step is to collect and prepare data from Calgary Open Data website and Denver Open Data catalog. The variables we used in the model include the distance from water, slope, land permeability, and basin. We conducted visualizations of the variables in Calgary and compared it to the city's inundation map. From observation, all the variables are likely to have a relationship with inundation sites. To build our model, we first built a fishnet for Calgary. We then reclassified the variables values to 0 and 1, depending on their existence. For machine learning, we decided to choose slope as the variable, since slopes are more likely to be a strong predictor for flooding. We then divided the data into two parts, 70% for training and 30% for testing to build the flood model. So now we can validate our model performance.
From the density versus probability plot, the model is confident in predicting no flooding in areas with low possibility of flooding. For the flooding class, the density of predicted probability goes higher as probability approaches 0.1 and 0.3, indicating that the model is confident in predicting flooding in areas with 10% and 30% chance of flood. The diagram on the right indicates that our model is accurate. The outcome prediction map shows similarity to the current inundation situation in Calgary, with true positive and true negative taking up most of the study area. Then the model is used to predict the flooding areas in Denver. The same four variables are used as predictors. Here is the inundation prediction map of Denver. There exist many zones with high flood risk in the southwest and northeast parts of the city. These zones include links between city and airport, commercial corridors near downtown, and lots of residential areas. In conclusion, the Denver city government should take action to conduct a detailed flood risk assessment in high-risk flooding zones to identify vulnerable groups and infrastructure. For important infrastructures, implementing a flood management plan such as building flood walls and promoting better land use practices is a way to deal with potential risk. The city should also educate residents and businesses in those zones about flood risk and provide them with resources to prepare for and respond to flooding events. Moving forward, our model and findings can be used to inform future planning and mitigation efforts to reduce the impact of potential flooding, especially for those with similar geographical features.